Welcome back. Example 2 is the integral of sine to the fourth x dx. Now in this case we don't really have an odd power to save with the dx. If we see an odd power of sine or an odd power of cosine, we can immediately save it with the dx, convert all the rest of the even power into the other trig function, and then do a u substitution, if all we have are sines and cosines at least. But in this case we don't really have an odd power of sine or an odd power of cosine, so what do we do here? Well, here it turns out we can make use of another trig identity called the power lowering formulas. And those are up in the table of know these trig formulas. The power lowering formulas are something that you learn in pre-calculus, and now they're going to be revived here, and we're going to make use of them. So here we have sine squared x equals 1 minus cosine 2x over 2, and cosine squared x is very similar, it just has a plus instead of a minus in the middle. So what we're going to want to make use of is the power lowering formula for sine x. So sine squared x equals 1 minus cosine 2x over 2. Now we have a sine to the fourth x, but that's not too hard to write in terms of sine squared. We can write this as sine squared x quantity squared dx. Then use the power lowering formula on sine squared x, so we'll have 1 minus cosine 2x over 2. And then what we want to do is expand this out. And there's a way of thinking about it that can help simplify your expansion. One is to, the way of thinking about it is you can take the 2 squared that's on the bottom and pull it out as a fourth. That way you don't have to write everything as fractions anymore. You pull the fraction out. So pull that out as a 1/4 and then square the top. Remember that there's going to be a middle term when you do a minus b squared. There's a middle term. So we're going to have 1 minus 2 cosine 2x plus cosine squared 2x dx. Now the 1 we can integrate. The 2 cosine 2x we can integrate. Cosine squared x we can't quite integrate just yet. That's not one of our basic functions when we have that square there. But if we have a cosine squared, if we have an even power of cosine, we can lower the power again using a power lowering formula. So here we have cosine squared x equals 1 plus cosine 2x over 2. So we can make use of this power lowering formula. The only difference is that we have a 2x inside of the cosines instead of an x. So instead of the cosine 2x over to the right, we'll have cosine 2 times 2x. Just replace both of the x's with whatever you have inside, which in this case would be 2x. So you'd have cosine squared 2x equals 1 plus cosine 2 times 2x, which is 4x, all over 2. Oop, went a little too far there. So let's take that step over to the side here. We're going to focus on the integral of cosine squared 2x, which will be the integral of 1 plus cosine 2 times 2x, which is 4x, over 2 dx. Now, once again, the fraction part we can pull out, so we'll pull that out as a half, and we have 1 plus cosine 4x dx here, which is a half. And then integrating term by term, we get the integral of 1 is x. The integral of cosine 4x will be like sine 4x, but because we have the 4 inside with the x, we're going to have an extra 1/4. That's to cancel off the effect of the chain rule. Like if we turn back around and take the derivative of sine 4x would be 4 cosine 4x. But we want to see a 4 here, so we have to have this 1/4 to cancel off that 4. That would come out by the chain rule. Now technically there's a plus c here, but we're not going to worry about that. We'll put that in at the end. We can distribute the half. And so what we've got here is 1/4 times the integral of 1, which is x. The integral of 2 cosine 2x will be just sine 2x. Right? You can take that coefficient and multiply it by a half, and then it disappears. That way, when you turn back around and you take the derivative of sine 2x, you get cosine 2x, but then times the extra 2, which is the derivative of this inside. The derivative of 2x gives you 2. Again, by the chain rule. And then the integral of cosine squared 2x we did off to the right, using our power lowering formula and then integrating term by term. So we got 1/2 x plus 1/8 sine 4x. Before I forget, I'm going to put the plus c at the end. And then, just to be nice, I'll simplify. So x plus 1/x, 1/2 x is 3/2 x times a fourth would give us 3/8 x. And then distribute the 1/4 to the rest of the terms. So minus 1/4 sine 2x plus 1/32 sine 4x plus c. Okay, so that's example 2. Anytime you see even powers of sine and cosine multiplied together, then you'll want to use this power lowering formula technique. So the summary down there at the bottom of the page is for integrals of the form sine to the mx times cosine to the nx dx, so power of sine times a power of cosine, can be done in one of these two ways, depending on what the powers are. So if either of the powers is odd, so if m or n is odd, then you'll save one of the odd factors to be with the dx, then use the sine squared plus cosine squared equals 1 to convert all the rest of the even powers of that trig function into the other trig function. So if they were even powers of sine that were left over, you convert them to cosine. If even powers of cosine, you convert them to sine. But if both the exponents are even, which is the other possibility, then you'll use your power lowering formulas. Sine squared x equals 1 minus cosine 2x over 2, and then the one for cosine squared x, which just has a plus in the middle. So now we can handle integrals of powers of sine times powers of cosine using this technique. Thanks for watching. See you in the next part.